Hello and welcome back. Let's do a proof. We are given angle C and angle D are supplementary and the measure of angle B is equal to the measure of angle D. Prove AB is parallel to CD. So prove these are parallel. Okay. So let's write out our thoughts to the side and see what we come up with. If angles C and D are supplementary, then that means that the sum of their measures is 180. So measure of angle C plus the measure of angle D is equal to 180 degrees. And we're also given that the measures of B and D are equivalent. So by substitution, we can put this here. And so angles B and C are supplementary, except that is not what we can use to say that A, B, and C, D are parallel. We have to show one of two things, that either alternate interior angles are equal in measure, or that corresponding angles are equal in measure. So I just want to extend this part just a little like that. Let's also write in a few points. Let's say points E and F, because I want to be able to talk about this angle right here. So in the diagram, we'd show B and D were equivalent like this. And we know that this angle plus this angle is 180. But what's the relationship between these two angles? Let's find out. So if we look at this, that's a linear pair, and so the sum of their measures is also 180. Measure of angle C plus the measure of angle ECF is equal to 180 degrees. Well, since both of these equations have measure of angle C, we can rewrite them and then show that these are equivalent. Okay, so let's start writing in our proof. Number one is what we were given, which was that C and D were supplementary, and this is what that means. Some other measures is 180 degrees, and we were also given that the measure of angle B is equal to the measure of angle D. Okay. Then we came up with this line. Measure of angle C plus the measure of angle, was it ECF? ECF is equal to 180 degrees. How do we know? Because linear pairs form supplementary angles. Okay. So if we rewrite this in terms of the measure of angle C and do the same thing here, we would have measure of angle C is equal to 180 minus the measure of angle D. And for the second, we'd have measure of angle C is equal to 180 minus the measure of angle D. We just did the subtraction property of equality. Which tells us that if we subtract the same amount from both sides of an equation, we have an equivalent equation. Well, if we know that this is equal to something, and this is equal to that same something, then it must be that these are equal to each other. Actually, they are, because I miswrote them. This is supposed to be ECF. Measure of angle ECF. Okay. Oops. So let's have that be our next line, that these are equivalent. 180 degrees minus the measure of angle D is equal to 180 degrees minus the measure of angle ECF by transitivity. And then if we did minus 180 on both sides, we'd be here. Minus 180 on both sides means we did the subtraction, or we used the subtraction property of equality as justification that that was legit. Okay, and then divide both sides by -1 because we don't want negative measures. We know that's legit by the division property of equality, which tells us that if we divide both sides of an equation by a non-zero number, we have an equivalent equation. Okay, so these are equivalent. Where is that in our diagram? That means this angle and this angle are equivalent. But based on them giving us this, that means that this angle and this angle are also equivalent. Those are alternate interior angles. So we're almost done. We can say that by substitution, instead of writing D, we can write B. Measure of angle B is equal to the measure of angle ECF. And that AB is parallel to CD, because if two lines are cut by a transversal, such that alternate interior angles are equal in measure, then the lines are parallel.